Environmental Flows Workgroup meeting. So just a reminder, this, as was probably just notified to everybody, this meeting is being recorded. So please go ahead to make the recording as smooth as possible from a camera standpoint, and as well as muting and so on and so forth. Please turn your camera on if you'd like to go ahead and speak. Otherwise, go ahead and keep it off. And then also make sure that you are muted throughout the meeting unless you are up to speak. If you have anything you want to add, you can always raise your hand. You can drop some stuff in chat. We'll try to make sure everybody gets an opportunity to speak on any of our agenda items. If those aren't working, you can just also give a holler and we'll hear you that way. So our agenda for today, just kind of briefly going through introductions and some housekeeping. Then we'll go into a couple presentations that we have lined up for everybody today with the CDFW's SEF application efforts, as well as a drought flows tool that Julie Zimmerman will present on behalf of TNC. And then we'll just kind of go into more of our round robin with some drought updates and then wrap up. So a little bit of a shorter meeting today, agenda-wise. And with that, I think what we found in the past is that going through all of the introductions is very time consuming. So if everybody can just do their best to have their name tagged in the, as you kind of pop up in Teams, that would be excellent. I believe if you go to, and I probably should have thought of this before I started the meeting, I believe there's a way to adjust how you're shown up in the chat or in the meeting list, but I don't know what that is at this point. Anyhow, without further ado, I just want to do a quick, just general roll call of folks. So I know we have water boards folks on because myself and some of my staff and whatnot are on. Do we have any regional board representatives on the call today?
This is
morning,
Jeremy
Dan.
Haas from Region 9. How are you guys doing? Sorry to cut you off there. Thanks for having us.
And this is Brian McFadden from the North Coast Regional Water Quality Control Board. Good morning.
This is Adam Sang from Region 4.
All right, and I know we have water rights staff on. Do we have any water quality staff on? Or Office of Enforcement or other board staff outside of water rights? All right, how about CDFW?
Sorry, Dan, this is Angela Quant, ORPP. I missed the board's window.
Oh, hi, Angela, thank you.
Yeah, and Stephen Barlow from Wetlands Permitting and Enforcement Boards. Good morning.
All right, and I know we have some CDFW staff on as they're presenting.
Hi, this is Brianna Drescher with CFW Water Branch.
Hi, Alyssa Ovister, Water Branch. This is Alyssa Marquez with CDFW Region 6 Habitat Conservation Program.
And Alex Millward here with CDFW Water Branch.
And how about Department of Water Resources?
Yeah, good morning. This is Dean Messer, Manager of the Division of Integrated Science and Engineering at DWR.
This is Brian Barnhart. I'm Office of General Counsel, DWR.
And Diane Penny.
Go ahead.
Sorry, Diane Penny, Office of General Counsel, DWR.
I'm Yarkovechi, Manager of Division of Planning at DWR.
Lucian Filler, Go ahead.
Go ahead, Norman.
This is Norman Johns in what used to be called the Bay Delta office. Now it's called the Modeling Support Office.
This is Lucian Filler. I work in the department or the Division of Planning with Kamiar Kavechi.
All right, do we have any other state agencies represented today?
Yeah, this is Aaron Hammond from the Streamflow Enhancement Program of the Wildlife Conservation Board.
Hi, Chris Kwan, Delta Stewardship Council.
All right, let's move over to federal agencies. Anyone from National Marine Fisheries Service? I'll open it up to any federal agencies.
Yeah, good morning, everybody. This is James Lee from work for the Bureau of Reclamation on the Trinity River Restoration Program.
Okay, my hunch is this is where it starts to get a little messy, is that when we move into the local agencies or the NGOs or other folks that are participating. Maybe to facilitate some of these, if you would like to introduce yourself to make it quickest and easiest, maybe drop a quick note with the agency that you're representing in the chat. That would probably be the fastest way to move through the rest of the folks on the line. It looks like we have 72 today. And then we can go ahead and move on to the first presentation. But before I go there, was there anything anybody wanted to flag at the start of the meeting that's not on the agenda to add? All right, so I think we can go ahead and jump right in here with CDFW's presentation on their application of SEF.
Let me just share. Can everybody see that?
Yes, we can.
Yes.
Okay, great. Hi, everyone. My name is Alyssa Obister, and I'm a senior environmental scientist in the in-stream flow program at Water Branch. And I'm also a member of the SEF tech team. And today I'm going to be talking about how we at CDFW are using SEF tools in our watershed wide in-stream flow criteria reports to develop flow criteria. So just to start off with a little bit of background on our program and what we do, we are based at headquarters in Sacramento, and so our work has a statewide focus. And broadly, we develop in-stream flows required to maintain healthy conditions for aquatic and riparian species. And we provide technical flow-related support to other CDFW staff. And we do this by developing site-specific technical in-stream flow studies. We do this by developing desktop-based flow criteria, which is what I'm going to be talking about today. And then we also do some other flow-related information to support drought and other regulatory processes. So the flow program at CDFW is non-regulatory. And if we look at this SEF diagram that is from the SEF tech report that kind of outlines each one of the sections, you'll notice that the work that CDFW does is focused on sections A and B of SEF. So what we do is the science to identify what flows are protective for fish and wildlife. And then if you look to the right side of the slide here, you can see how our work fits into the flow objective setting process. So at CDFW, we conduct flow studies, we develop flow criteria, and we sometimes develop flow recommendations. And then we provide these criteria or recommendations to the water board, and then the board can use these numbers to develop flow recommendations or objectives or inform other water allocation decisions. So with that background, I'm going to jump into talking about our watershed criteria reports. So we are applying functional flows, a product of the CEF work group, in our watershed criteria reports. These reports are a rapid alternative to those site-specific technical studies, and these reports rely on existing data sets and tools like the functional flows database. In these reports, we use functional flows as the basis for establishing flow criteria, which I'll talk about a little bit later. And these flow criteria help develop flow regimes that incorporate intra and interannual variation. And these watershed criteria reports, like I said, are developed using existing data sets and tools, but they can be combined with site-specific data when these data are available. We prepare these watershed criteria reports for priority streams based on legislative mandates, including those identified in the California Water Action Plan. We also prepare these reports based on specific requests from other CDFW staff that may have questions related to flow. And in general, these reports are intended to serve as a tool for consideration in water management planning. So diving into the actual reports, we divide the assessments in each one of these watershed criteria reports into 3 categories: base hydrology, desktop analyses, and site-specific analyses. The base hydrology analyses use either estimated or gauged flow data, and they're intended to provide some context into the watershed's hydrology. And this is an area where we use one of the key CEF tools, the natural flows database. And the natural flow numbers help us, like I said, get some insight into natural hydrologic patterns in the watershed. The next assessment type are the desktop analyses, as the name suggests. These rely on tools that we can use from our desks, so they don't require any field data collection, and they rely on existing data sets and tools. And functional flows is the key desktop analysis mentioned here. And then lastly, when these data are available, we have our site-specific analyses, but we don't necessarily always incorporate these into our watershed criteria reports. And for the purposes of this presentation, I'm just going to focus on functional flows and how they're used to develop flow criteria in the report, since that's what's most relevant to this group. But if you're interested in learning more about each one of these assessments or the watershed criteria reports in general, please visit our website, and I'll make sure to include this link in the chat after I'm done presenting. So as a reminder, functional flows represent these key points of variability in the natural flow regime that serve these distinct chemical, physical, and biological functions. Each one of these functional flow components are quantified by functional flow metrics. These include the magnitude, timing, duration, and rate of change of flows. So you can think of each one of those metrics in the table on the right as describing the placement and size of each one of those boxes. And just to reiterate, kind of looking back at this hydrograph, the blue line represents what we might think of as a natural flow regime, where the red dashed line indicates what a functional flow regime might look like as it hits on those key points of variability throughout the year. And this is what we think at CDFW is a key strength of this functional flows approach, because there's this explicit communication around the importance of variability, both within and across years. So this slide is just kind of an example of how we present the functional flows in our reports. There's a lot of numbers, don't worry about the specifics right now, but generally we present tables like this for several reaches of interest within the watershed. You'll notice in this table, the functional flow metrics are provided for 3 different water year types. And then in each one of those cells, there's 3 numbers. So the first number represents the median flow metric value. And then the second set of numbers in parentheses represent the 10th to 90th percentile range of modeled flows. So as an example, if we look at the wet season base flow magnitude in moderate years, you'll notice that the median magnitude in moderate years is about 654 CFS. And like I mentioned before, functional flows make up one of the assessments in the watershed criteria reports. But like I said, if you're interested in learning more about the other assessment methods, visit our website. So flow criteria synthesize and use information from the other analyses that I referenced, but functional flows provide the basis for the development of the criteria, and other analyses in the report are evaluated against the functional flow numbers. We use functional flows as the basis for flow criteria because they are broadly ecologically protective. And so they're not focused on a particular species or life stage. And the flow criteria are intended to serve as a tool for consideration in water management planning, and we develop criteria for several sites of interest within the watershed. So kind of to look at this in a different way, we use functional flows in addition to other analyses in the report to develop flow criteria. So functional flows help us get at broad ecological needs and chemical and physical functions, both within and across years. And then we use information from our additional analyses to help us identify any specific species or ecosystem flow targets. So we use this information together to develop flow criteria and flow regimes. And these flow regimes incorporate some of the important variation in flow from year to year and season to season. So this is an example of what flow criteria look like in one of the reports that we've released. You'll notice that kind of similar to the functional flows table that we were looking at, we present the criteria by water year type. So for wet, moderate, and dry year types. The criteria are generally presented by season. So the wet season and the dry season. And again, the timing of those seasons are based on the functional flow timings. We provide a little bit more detail during the spring, during the recession period. So those criteria are provided at the weekly time step. And then you'll notice, it might be kind of hard to read here, but there are some footnotes under the table. And those indicate, could we maybe mute? Those indicate the pulse and peak flows that should be preserved as part of the criteria. They're not included as part of the table, just because they're a little bit harder to visualize, but those are also key points of the criteria that we'd want to preserve. And then this is an example of how we take those criteria and how they could be used to develop a flow regime. So we also include this type of figure as part of our reports that basically take what's in the table and construct a flow regime. So you'll notice that kind of like that functional flows figure that we were looking at, each one of those functional flow components is represented on this flow regime. And in this case, this was a site where we had some reference hydrology information. So that's what those gray lines on the figure represent, but they're helpful in providing some context to see how the proposed flow regime kind of fits into the natural hydrologic patterns. All right, so that is all I have. We have reports available for a variety of streams on our website, including the West Fork San Gabriel River, the Fresno River, the Ventura River. Most recently, we released the South Fork Eel River Watershed Criteria Report, and we are in the process of preparing a watershed criteria report for Mark West Creek, and that should be released at the end of the month. And like I mentioned, the reports and the supporting documents related to the watershed criteria reports are available on our website. The link's here, and I'll paste it in the chat. So thanks for listening, and I'm happy to take any questions.
All right, it looks like Conrad, we'll start with you.
Thank you. Great presentation. I guess two questions. What's it take to go from a criteria to a official CDFW recommendation? And second question, what's the status of the Shasta? It's one of the 5 streams named in the Water Action Plan, but it's not happening.
So the first question you were asking, criteria to recommendations.
Right, because you got to get to a recommendation before the water board will actually give the fish what's recommended.
So not necessarily that the water board can take the criteria and use it. But as far as criteria versus recommendations, recommendations have director approval, so they need to get like a higher level sign off. I don't know, Brianna, if you have anything to add to that.
Hi, this is Brianna Drescher with the Water Branch. Yeah, like Alyssa said, the recommendations we work really closely with Region to come up with the recommendation and dive into really heavily into species needs and like the watershed characteristics. So the recommendations they do go higher up the chain for approval, and then we do spend a lot more time working it through with Region and making sure that Region is on board with the numbers that we're putting out there, and it makes sense because ultimately there are regional experts for the watershed, so they have a big role in the recommendation process. As far as the Shasta goes, we have a set of study plans that were developed a few years back for the Shasta, and we are hoping at some point to be able to fund those and execute the study plans in that watershed. But as of right now, the Shasta is really, the state water boards got them under emergency regulations and curtailments and that type of thing. So that's kind of the focus of the Shasta right now.
Thank you.
Norman.
Thanks. That was a great presentation, Alyssa. It was great to see that that's being applied. Could you, is it possible if you go back to your presentation on one of your tables? I wanted to ask a question.
Yeah, let me pull that.
On slide 8 in particular.
Yeah.
I guess it's also on another slide too. Here, the metric down there on the bottom where you have a 2-year peak flow.
Mm-hmm.
And then later on, there's a 5-year peak flow. In some other states that I worked on, there was a little bit of a recognition, if you will, that if you got the 5-year peak, and I'm talking about a watershed that's fairly well regulated. In other words, the onus, if you will, is on the water managers to try to meet these criteria, let's say. So, if it's kind of a high runoff period and they're doing maybe making a little bit of an extra release to hit that 5-year peak, they would, there was an expectation that then the necessity of meeting the 2-year peak would be relaxed for some period of time. And this is all subject to lots and lots of negotiation and so on. But I think from an ecological point of view, you could, justify that. If you're imagining that those large peaks, do ecological things like rearranging gravel bars and cleaning the substrate and all these kind of things that we attribute to those high flow peaks in terms of value, then you wouldn't necessarily need to repeat that for a while. Do you envision any, and I know this is far from a regulatory stance we're talking about, but I just wanted to kind of put that out there and see if you thought that there might be some latitude for incorporating some flexibility in this if it were to move into like an implementation arena.
I think that's a good question and a good point. I think, at least from our perspective here, we're focused on just the ecological needs and like the functionality of a 2 versus a 5 versus a 10-year peak flow event. But I could see maybe moving on into the negotiations in Section C. That could be something to consider that, yeah, maybe you do only need a 5-year and the 5-year would also cover the 2-year. But I think that would be more of a balancing thing that's outside of the scope of what we would do, at least.
Yeah, and I can, it would take a lot of like monitoring to follow up to see if you were really getting the functions that you needed out of that. And it's also a very long-term proposal to track.
That's a good point. Thank you.
And then I would just add, Norman, and I would like the tech team, also chime in. But that 2-year event kind of helps maintain the active channel more so than kind of rearranging the pool ripple combinations and point bars and stuff like that. So you might start to increase your width to depth ratios in the low flow season without a 2-year peak, for example. So that would just be something to be evaluated. Any other questions for Alyssa? All right, thank you.
Could you just repeat the names of the rivers where you've already completed your analyses? The very end.
Yeah, I'll put them in the chat right now.
Thank you. Perfect. Thanks.
All right, so next up on our agenda is overview of the drought flows tool that TNC has put together with Julie Zimmerman.
Hi, everybody. I'm Julie Zimmerman. I'm lead scientist with the Nature Conservancy, and I'm a member of the CEF technical team as well. And what I'm going to be talking about today is it's not a direct CEF product, but it builds off some of the CEF tools, and it's something that you'll be able to find on the Natural Flows web app. I'm going to share my screen here. Okay. Sorry about this. I'm not proficient in Teams. I'm more of a Zoom person. It takes me a couple minutes. Okay. There we go. Hopefully everybody can see this. Please go off mute and pipe up if you're having trouble. So what we're calling this the Drought Flows Monitor, and what we wanted to do is create a tool that could be used to help us understand drought conditions in streams where we don't have stream gauges. Really a statewide tool that helps us look at what potential drought conditions are and engaged and ungaged watersheds based on natural flows. So this isn't based on actual flows that include human use, but what we would consider to be drought conditions if there were natural flows everywhere in the state. And we base this off of our natural flows data set. So if I think a lot of you have gone to our natural flows web app, which is where you can download all of the functional flow metrics statewide. One data set that's also available on that tool are monthly natural flows from 1950 up into the present time. And I think I've talked about this before with this group, but originally we had modeled monthly natural flows for all streams statewide from 1950 to 2015. In the last several months, we've actually extended that data set. So we've updated our models. So now we can predict a monthly natural flow about a week to 2 weeks after the month ends. So we have it through July of 2022 and are continuously adding months as time goes on. We're dependent on releasing PRISM data, and once that is out, we can come up with a new prediction. So this tool is based on the natural flows database, the monthly flows, not the functional flows. And when you look at that database, you can download for any stream segment, any COM ID, natural flows for each month. And so we took those data for every COM ID in the state, and we calculated each monthly observation as a percentile of the range of predicted natural flows over that period of record. So we have 1950 to 2022, that's about 72 observations for any specific month, and we basically ranked them and calculated percentiles. And this is an example of what that looks like, this figure on the right here for March for one COM ID. So this chart shows the predicted natural flow for the month of March from 1950 to 2022. And every blue dot here is a monthly natural flow prediction. And then we just calculated the percentile for each observation and decided that anything less than or equal to the 10th percentile of the distribution of natural flows would be considered critically dry conditions. So again, this has nothing to do with flow alteration. This just says that if you're less than or equal to the 10th percentile of natural flows for that month, then even under unimpaired or natural conditions, your stream would be considered to be critically dry. We did this for every COM ID in the state, but it gets messy pretty quickly if you want to look at patterns of drought and water availability. And what we ended up doing is summarizing by what we call large name streams. So they don't exactly translate to a HUC 8 or 12 level, but it's basically taking a unit of measurement that is equivalent to kind of a named watershed. And then we used the downstream most reach of the largest river as a way to summarize conditions for that watershed. We then put these percentiles into categories. So we had said anything at the 10th percentile or below we would consider to be critically dry, but we wanted to parse that out a little bit more. So we ended up using the categories in the US Drought Monitor. So I'm going to show you some maps of our results in a minute, but anything that's that kind of dark brick red is considered exceptional drought. And for our data set, these are the lowest predicted values over that entire period of record from 1950 to 2022. And then extreme drought, or the red, would be the 5th percentile or below. Severe drought, or the orange, is the 6th to 10th percentile. And then we had 2 additional categories that were above that kind of critical threshold, but showed when conditions were getting dry. Moderate drought, which was the 11th to 20th percentile, and then abnormally dry, which was the 21st to 30th. And that just follows the US Drought Monitor categories. And then here's some of the results. So this set of charts shows the wettest year in that period of record and the driest year in that period of record, according to the Northern Sierra 8 Station Index. So 2017 was the wettest, 1977 was the driest. And you can see that our method really does pick that up. So if you look at March, April, and August of 2017, you can see that we don't have much drought stress showing up even in natural conditions in these watersheds. There was a lot of rain. But then when you look in 1977, you can see how these watersheds really pop, a lot of them that dark brick red, which were the lowest ever predicted values, particularly for Northern California, the North Coast, and the Central Coast. When you get into the Southeast, 1977 wasn't quite as dire. So there is some differences in the spatial patterns of how different watersheds were affected or experienced drought in that year. And this is another set of 2 years for comparison. This is kind of from our last, extended drought period from 2011, which was a wet year, going into that 2012 through 15 period, which was dry. So this is comparing 2011 to 2013. And in 2011, again, we had pretty good conditions throughout the state. By August, we saw some dry conditions showing up in the eastern part of California. But then you can compare that to 2013, where we did see a lot of drought conditions showing up with unimpaired flows. And this seems to be centered more in really the southern part of the state. So again, you can see those spatial patterns showing up. And then this set of maps is a little bit different. This is for the last 2 years, 2021 and 2022. So again, we don't have August of 2022 yet. We'll have to wait until the first week of September until we have those predictions. So this compares March, May, and July of the last 2 years. And 2021 was a really dry year. So you can see that by March, conditions were dry throughout much of the state. They got worse in May in most places. And then by July, particularly in the Northeast, we saw some of the driest ever predicted conditions. And then if you compare that to 2000 or to 2022 to this year, March started off really dry. Everybody was really concerned. And then in kind of between March and May, we had some storms in April that really alleviated some of those drought conditions in the North Coast. So by May, the North Coast was looking much better, but the Sacramento River and some of the tributaries to the Sacramento were showing some of the lowest ever conditions. So again, those spatial patterns. And then by July of this year, it seems to be centered more into the San Joaquin. And over on the left here, there's a website for an interactive dashboard. So we have been putting together a tool in Tableau where you can go and select any month and any year over that period of record and look at what comes up for the maps. We don't have it publicly available quite yet. We should within probably next week. And we're going to link to it from the Natural Flows web app. So when you go to the Natural Flows web app to look at the monthly natural flows or the functional flow metrics, they're on that kind of front landing page. There will also be a link to this Tableau site where you can go and explore these data. And I just wanted to show some examples for a specific place. So this is the Navarro River watershed that's highlighted on the left. This shows April of 2020 and July of 2020. So this was a year when the North Coast was dry and the Navarro was in the extreme drought category. And then on the right, this is gauge data. This black line is observed gauge data for the Navarro River gauge for that year, overlaid on the percentile values for gauge data across the period of record available for that gauge. So when the black line is in the green, it's in kind of the normal 25th to 75th percentile category. When it's in this dark brown, it's in the 10th percentile and below. And if it ever goes below the dark brown, it's kind of in that lowest, the lowest ever predicted category there. So you can see that in the winter, things were pretty normal, but by March and April, that even the gauge data was looking really dry, and then it kept trending dry throughout the rest of the year. So it matches, the gauge data matches pretty well what we're showing from our natural flow predictions. One difference though is that the gauge data also accounts for human use, right? This is not unimpaired. There is human use in the Navarro watershed, and so it's not going to match perfectly. But we do see those trends are following. This is the same set of maps for this year. So the top watershed, or the top one is March of 2022, when the Navarro was in the severe drought category. And then the bottom panel is July. And so again, we had some rainstorms in April. It pushed the Navarro flows up into the normal or wet category for predicted natural. And if you look at what's happening with the gauge data this year, in March, it was super low. It's actually showing lower than what we predicted, potentially because of human use. And then those April storms pushed it back up into the normal or even wetter categories, and then it kind of trended back down again. So when you go to that Tableau site, there actually is a dot for every gauge that links to this site right here. So you can go into the Navarro watershed, look at what we would predict for the drought categories, click on the link to the gauge, and it brings you to this WaterWatch website where you can look at how the gauge data for that year compares. And so these are just some of the insights that we came up with going through this project. We did this originally to focus mostly on the North Coast with the Salmon and Steelhead Coalition, but we brought in Alyssa from the In-Stream Flows program and Robert Holmes to kind of help us think through how we might look at this statewide and be a useful tool for us to kind of look at what drought conditions might be and maybe think about how it could inform drought actions. And what we found from this is that critically dry conditions in the late spring and March, April, that time period, they're really unlikely to improve over the dry season. We did see that this year, but that's really rare. I haven't seen another year where that happens. So March and April conditions tend to persist. Those same percentiles trend all the way through to August. you need to evaluate late season storms, but they need to be, pretty good size to bring any watershed out of that drought status. And it tends to only happen in those rain dominated watersheds. So any place that's dominated by snowmelt, a late season storm isn't really going to bring it out of that drought status. We also saw that many individual stream reaches go dry by late summer, even under normal conditions. And so by the time you get to July or August, there's just not a whole lot of variation between a wet year and a dry year, except for the larger streams. So summarizing by larger watershed evaluates conditions in those perennial streams and is a good indicator of the overall watershed conditions. So it kind of summarizes what's going on in these smaller streams that tend to hover near zero by that time of the year. And then natural flow conditions that are expected to be critically dry, we also, this is something that makes sense, but it really illustrated it for us. They'll result in ecosystem stress at any time of the year. So when we started this, we were concerned about places that might go to zero earlier than you would expect, or hit zero in the summer when they might not have. But really, any of the streams that are getting really low runoff and having low flow, even in the spring or the winter, they're going to show drought stress, and it often persists throughout time. So even if it doesn't hit zero, it's stressful for ecosystems. And so reducing alteration or thinking about how you might reduce alteration from human use would be warranted. So as I mentioned, we have a Tableau site. It's all ready. We're just kind of finalizing some of the documentation, and we're going to link to the Natural Flows web app. That should be out next week sometime, so I can send a link to everybody, but I'm happy to take any questions.
All right, looks like we got some hands up. Give me just a second. Chris Milan.
Good morning. Yes, back at your last frame on your presentation, you said something about streams always go dry in August. Many streams always go dry in August. Did I read that right?
Not that they always go dry, but many streams in California are at their driest point in August. A lot of them do go dry, not all of them, but there's much less flow variation between years by the time you get to August, because it hasn't rained in most places since maybe April, and they're just at such low flows that you don't see a whole lot of variability between years. So it's easier to pick up drought stress in a month where you have a lot of variation among water year types. So like in April, in a wet year, you'll have really high flow. In a dry year, it'll be really low. You don't see that same spread among years by the time you get to August. So it's much more difficult to pick out differences. Not everywhere. Again, the big perennial streams are different, but in some places.
Yes, but is this summary that you've got here is based on where the gauges are? Is that right?
No, our summary, if you go to the Tableau site, it's based on predicted natural flows for every stream reach in California. So it's based on our monthly natural flow modeling, which has been published. Can give you links to that paper, but it's not based on, we built the models based on reference gauges, but it is not just at gauge locations, and it has nothing to do with altered gauges.
Because in the Napa, I am out in the watershed a lot, and above the impaired flow, there's good flow in most of the streams above the impairments. And that was last year. And I've seen, and that these are at reference sites where we've been monitoring. Some of them are reference sites and some of them are above impaired flows. We get up to like above 10 CFS. So I'm just questioning, making that kind of broad statement for the whole watershed when you get higher up in the watershed and above the impairments, you get year-round flow.
Yeah, I'm not saying anything about places not having year-round flow. That's not what I'm trying to say. What I'm trying to say is if we're looking at drought stress, we should be looking at the springtime first, and then realizing that even if like you do see 10 CFS, it's not going to vary that much over year types. You're unlikely to see in August with 100 CFS, for example. So like in a good year, you might see 15. In a bad year, you might see 3, but it's not going to be as much of a variability as you'll see in a wetter time of year.
Thank you.
I guess my point is that it's easier to look at drought conditions in the late spring and then assume that those are going to persist through the summer, the same percentile, not the same flow value, if that makes sense, unless you have a late season storm that changes things like this year, which is pretty rare.
Yeah, so in drought years, Julie, we see a lot, well, drought to wet years, we see a lot more variability in the springtime than we do late in the summer season. So we know that flows will continue to recede down as we move through the summer. But the key critical time period that we want to evaluate drought stress is probably more in those April through May months to predict what's going to happen in the rest of the summer.
Right, exactly. Thank you. I think that was a clearer way of explaining it. Thanks so much.
Yeah. All right, so let's see. Next up, I have on my list, Norman.
Hi, Julie. Thank you. That was a very interesting presentation. I was wondering if I could ask you a question about one of your slides.
Sure. Do you want me to go back and put a slide up on the screen?
If you could.
Okay.
Challenging your team's acumen again.
I know, right? There we go.
Go back to one of the Navarro slides where you had that's a good one. The color bands that you're comparing the actual flow to, the black line, are those color bands your calculated, drought, exceptional drought, and so on bands? Like I know they were monthly, so I guess they're not. They're actual gauge.
So the panel on the right, those bands are based on gauge data that was calculated by USGS. So this is on the USGS Water Watch website. They do the calculations. This is just a screenshot of that site. And they calculate the bands based on gauge data. On the left is what we calculated based on the natural flow predictions and the categories that we put it in. So you would not expect these to match in, in places where you have altered streams. It's just an idea to, it just shows you like how our predictions might follow what you're seeing in the gauge data.
So those flows that are present there in late March, early April are off the bottom of the chart, so to speak.
Yes,
in terms of
those were
historical precedent.
Yes, those were observed flows. So that was not modeled. Those were observed flows at the gauge. Yeah.
That's why I thought maybe you were comparing to the natural, but this is actual historical. Okay. Wow.
Mm-hmm.
All right. Thanks.
Yes. So we predicted for that March time period, we predicted severe drought category, the 6th to 10th percentile. They saw something worse at the gauge. And, maybe it's because our model didn't pick that up, or maybe it's because alteration, there was just a lot of diversions right then. It's hard to tell comparing it to gauge data, but yes, on the right, that's all observed data. So again, once you can go to our Tableau site, it links you directly for any gauge to this Water Watch website where you directly to this chart, so you can look at it for any location.
All right, next up is Conrad.
Thank you. This is some of the most amazing fish flow science. It's really good. Thank you. I'm curious if unimpeded and natural mean the same things. In the public dialogue, unimpeded, I believe, means absence of diversion. Diversions, among other things. Does natural mean the same thing? Second, and I'll be quiet, how do we know what's natural in places where we don't really know how many diversions are coming off a creek? I've trumped around a lot of the Mid-Klamath, for example, and there are tons of diversions that are not registered. They're either illegal or not registered because they're riparian or unregistered pre-14.
Right. So unimpaired usually means that you know what's being diverted and you add it back in. We did not do that, which is why we're calling it natural. We took reference gauges and created models. This is the same method that we use for the functional flow metrics. We created models using machine learning by looking at patterns at the reference gauges and then predicting at ungauged sites. So it should be mostly natural land use and all those other things. It's not just adding the diversions back in. Did I answer both of the questions or?
Yeah, so the first one very well, thank you. Okay. The second is how do we know what's natural in places where we don't know how much water is being taken out? And I gave the example of mid-Klamath tributaries where there's lots of unlawful and or unregistered diversions. Is there a way to spy them from space yet?
Yeah, at ungauged sites, it's difficult to look at to assess performance of the models, but we did a lot of model performance estimates when we did our modeling originally. So the functional flows paper on modeling used a similar method to look at how our models predicted flows at gauge locations, at reference gauges. We did the same thing when we did the monthly natural flows, which predated the functional flows effort. So I can share that citation with you if you're interested. It goes into the whole assessment of our model performance. But you're right, at an ungauged site, it is very difficult at this point to really see how well you're doing. All you can do is see how well you're doing at gauges, and then hope that if you're kind of within the same bounds of your model, that you are doing well at predicting in those places.
Thank you.
And then one thing just to add on that is just to be aware is that if there is potentially significant disturbance in that watershed, it might not be picked up by the model, such as for the functional flow metrics or the natural flows model, there's significant development or channel alteration. Just be aware that those might influence how flows are actually behaving in the real time from an unimpaired or natural standpoint. Let's see, next up I have Margaret.
Hi, I had a kind of a vague comment question. It seems like the prediction of the drought condition is based just on kind of a really recent flow, and I'm wondering if there's any way to start incorporating the recession curve, something earlier, some other indicator, using a recession curve to in a flow rate to start trying to predict it way ahead of time, so that we, like if we know with this recession curve and this flow, it's going to go dry, we could react a lot sooner. So that's my
right. So we've actually had a lot of discussion about that. Especially with some of our partners in the Salmon and Steelhead Coalition, because Trout Unlimited is doing a lot of work with the recession curves. So what we're doing is we're predicting for a given month what's happening. We're not forecasting into the future. And that's something we may do as a next step. But right now we're just saying, like, based on the data we have about precipitation and what happened in previous months, this is what we think the flow status is for this month that just happened. So I could show you the July 2022 data. I think when you bring in those recession curves, you're starting to try to forecast, here's what we think that means for, August, September, moving forward. And we just haven't tried to do that yet. That's a different project than what we were attempting to do.
It seems like it would kind of be the same thing, just a different metric to me. You're already predicting, well, if we have this flow, we'll probably get further severe drought. So that's a forecast. And so instead you could be saying, if we have this recession curve and this low flow, we're going to go dry. So anyway. But
yeah. I mean, it's right from a modeling perspective, it's a little different because we're taking precipitation data and temperature and all that stuff to make our prediction. And when you're forecasting, you're you're using different input data. But it's similar methods. I think it's something that we could probably work on. It just we haven't done it yet.
Thanks.
Yeah, thanks.
All right, thank you. Next is David.
All right, thank you, Julie. I had a brief follow-up on what you mentioned to Conrad about measured flow and then diversions and unimpaired and natural flows. In inland areas, diversion becomes an increasingly significant component of what flows remain. And given that some older water rights are what you might call overly liberal, and a lot of water gets wasted and returns to the stream, and junior water rights may not be even exercised at all. Can you expand a little bit on how you address those unknowns given the rather poor quality of reporting that exists in terms of net diversion quantity versus paper water right versus junior water rights versus senior water rights, and ultimately how much we can trust your predicted values in the real world?
Yeah, I think those are a couple different questions. So in terms of diversions and water rights, we did not assess water rights or diversions at all. Our method was to look at reference gauges where there were no diversions. The USGS came up with a set of reference gauges for the state, which are they determined didn't have any significant alteration. So no dams, no diversions, pretty natural land use. And we built a model to predict flows at those reference sites based on precipitation and temperature and lots of watershed variables, and then use that model to predict flows at ungauged sites and gauge sites that did not have reference gauges. So we didn't address diversions at all. It's just saying, based on our model of natural flows, this is what we think would have been in the river if there was no alteration. And then we wanted to look at drought status as if there's a natural drought, right? A drought based on natural conditions, adding any human use is going to make it even worse. So that's when you really want to, have some policies or some, voluntary actions or whatever it is in place to protect against further alteration or for having flows decline any further. So we didn't address that at all. I think when you're looking at, there's a next step to this, which is how altered are these places. So if you're already predicting that something's in an extreme drought category, how much lower are the flows in actuality because of all the diversions? We haven't got to that point. We are working on another project that's in the early stages to try to predict actual flows, but that's not done yet. We're just kind of starting on that, but this is, just natural. The second question there is, how do we know that it's right? And that's a similar question that I addressed earlier, which is, we looked at the performance of our models at gauges, at reference gauges, and that's really the best we can do right now. We know it performs well in those places. At ungauged locations, we just don't have the data for comparison. So, as we get new gauges online or new methods, we can start to improve these models and start to assess them more fully. But right now, we're kind of stuck to where we have reference gauges to be able to both build the models and assess how they perform.
All right, thank you, Julie. Let's see, I believe next up is Kimberly.
Can you hear me okay?
Yep.
Okay. Hey, Julie, thank you so much for all your hard work. It's very, very important, of course. I'm over here in Green Valley Creek on the Russian River. And I think maybe you kind of answered my question when you were talking to David's question, but it seems like it would, for my simple mind, it sounds like we have had, millennia and thousands of years of salmon runs, and those are diminished quite a bit. And we have had historic droughts. So, or droughts in historical times. So what's the difference? If there was some way to say that or explain that, we've lost, these salmon, and a lot of it is just rearing habitat that's gone, how those things kind of can be explained together. And, it's complicated probably on some level, very, very complicated, but it seems to me the loss of the habitat is kind of missing part of this. And I don't know, I'm kind of looking for just some sort of a summary of that. Yes, we have had historical droughts, but the salmon and anadromous fisheries and other critters have survived all that, and now we just aren't able. So is there a connection we can make in maybe in your science that can come out in layman's terms somehow? Sorry, I'm
yeah, I mean, that is, no, I get it. I mean, this tool has a very kind of specific.
I think we may have lost Julie for a moment there. I don't know if it's just on my end. So let's see. I'm sure she'll be back in a second. But while we're waiting for her to come back, I have David, Kimberly, and Chris still with your hands up. Did we address all your questions?
I'm good.
Kimberly, yours is ongoing.
Yes.
If you want to lower your hand, then that would be great. And make sure our videos
Can you guys hear
off.
me or no?
Now we can, Julie.
Oh, okay. Sorry. It didn't freeze on my end, so I didn't realize you guys couldn't hear me. I'm sorry. Yeah, so I was kind of in the middle of trying to answer that question. So I think that when we developed this tool, it was for a very specific application. It was to say, as we're going into a year that we know is dry, can we tell how dry specific watersheds would be if there was no human use of water? And just as a way to say, where are the really problem areas under natural conditions so that we know additional use of water is going to make things worse? How, spatially does it play out over the state? I think that there's a whole other issue, which is habitat related and the declines of our salmon runs and other ecological outcomes that are addressed in other places. It would be great to have this all together, connected in a more integrated way at some point. But right now, this is a new tool we just have come up with, and it's just for that one specific application. But I totally hear where you're coming from, that there's other things going on as well. We're just kind of pulling out one of these factors.
Thank you.
All right, so let's see here. Chris, did you have another question?
Yes, a clarifying question, please. Again, I'm going back to the reference sites and the location of the USGS stream gauges. My experience with those USGS stream gauge locations is that they're pretty low in the watersheds. Is that true for this data set?
So we didn't use all the USGS stream gauge locations, just the subset. There's about 250 that they designated as reference gauges. It's not every single USGS gauge, and they're pretty spread. I mean, there's not that many in the southeast or the northeast part of the state, like the Modoc and the Mojave. There's fewer there. There's fewer on the really big rivers, like the Sacramento main stem doesn't have a reference gauge, for example, because those places are altered. So they kind of tend to be, we have them in the North Coast. We have some in Southern California. We have them up in the Sierras and down in the foothills, but they're kind of those kind of the mid-size streams. But we do have assessments of the reference gauges relative to the whole gauge network and stream sizes in our original modeling paper. The citation and a link to that paper is on our web, the Natural Flows web app. So feel free to take a look. But we did have that. We published the model that we did, and also in that is an assessment of where the gauges are and the stream sizes.
Yeah, that I appreciate that, but I'm sorry, I guess I'm not being clear. So on a river, just a particular river, let's just, for example, say the Napa, because I know this one. All USGS stream gauges are low in the watershed near the main stem. None of them that I'm familiar with are on tributaries, say above the 50 foot level. Do you know that kind of information about your stream gauge locations within the particular rivers? Because the reason I bring it up is because a lot of times the USGS locations will show lower flows than what's occurring higher in the watershed. So I'm wondering if this whole study and this modeling may have a sort of false reading of what the flows actually are.
So we're not using, yeah, we're not using the gauge. Sorry, go ahead.
Yeah, because if you have USGS installations of their gauges, say lower in the elevation of the watershed, and that's how USGS installs their gauges lower in the watershed, and that seems to be the case on the Napa because they're very low in the watershed on the main stem, and I don't know any USGS gauges in the tributaries. I'm just wondering if that's true about your study, because it's a much different picture of what a watershed flow is the lower you are in the watershed. And that's true on a reference site as well. The higher up you get, a lot of times you get more flow. Until you get to a certain point, and then it diminishes because it's too steep. But do you see where I'm going with this, or is this
well, I don't think that pattern holds for all the other watershed, for all stream gauges. I mean, it might be true in the Napa, but we did not, for a given watershed, we did not use a local reference gauge. We developed the model based on all the reference gauges combined. So we just looked at patterns of flow collectively at reference gauges. So information from all 250 reference gauge sites were used to predict the flow at any given location. So things like patterns that are happening in the Napa shouldn't be an issue for the model. And from what we saw, that's not a pattern that holds up statewide. So it's not the case that USGS gauges are always low in the watershed. They're pretty, if you look at all of them in the state, the reference gauges, they're fairly well distributed. And we did not see that kind of bias in our results comparing model to gauge data. But it's, it's possible that there's weird things happening at any one specific location, and that, I mean, that is reason to maybe go into some more site-specific detail at one specific place if it doesn't make sense to you based on what you know.
Julie, would it be fair to say that based off the reference gauge locations, especially in some of our more coastal dominated streams that are rain dominated, that those locations are typically a little bit higher up in the watershed, and we don't have a ton that are kind of in that transition phase where it goes from a gaining reach to a losing reach. And so some of that, the location of where the stream starts to become a losing reach and when it becomes a losing reach is not quite as accurate from a prediction as the upper watershed, where it's a little bit more, where we have more reference gauges to predict that it's a gaining reach. or
I haven't, yeah, I mean, I think that's definitely possible. I haven't looked at that pattern specifically. We do know that we don't capture the groundwater, streams that have a lot of groundwater input. We don't capture flows there as well because we don't have as many reference gauges that represent those places. So yeah, I mean, we are limited to where you find reference gauges, and those are the patterns we will be most successful at predicting for sure. But I have not looked specifically at that transition between a gaining and losing reach.
And I think that's kind of what Chris is getting at, is that, you know, we have these transitions in these watersheds, and you know, the predictability, basically, you know, we look at it as our best available information. It was a very robust modeling effort that TNC did to predict this based off our existing gauges. So where we see more human development historically is going to be in those areas where there's more in the valley floors, where you have more water security and also have groundwater components or opportunities for folks. And so you have less reference gauges in those locations just generally in California. So
yes, I mean, that is very true. Yeah. Mm-hmm. Right. I mean, those lower reaches for sure are more heavily altered, and we just have very few unaltered streams to use as reference. So yeah, we're not going to be able to predict those patterns as well. I think you're right, Dan.
All right, so next up I have Dennis.
How you guys doing today? Hope you can hear me all right.
Yes.
My question was actually more of my own curiosity. I tend to be more of a systems thinker, in a sense, and I'm wondering if we're looking at infiltration rates as well as, like, say for example, with the community that is doing like water harvesting, maybe with a rain garden or observation well to check how much water is going into the watershed, and then getting an idea of how that correlates with any data that you have, or something like that going on.
Yeah, it could be. I mean, I think that there is, I think it would be useful to do different types of models in some of these places of concern and see, you know, how well they match what we've done. And if it's a place where you're really concerned about groundwater input or pumping or whatever it might be.
Well, basically, I don't have the camera on. Hold on. There we go. Basically, I'm saying more of how would you say it? It's not like we become part of the water cycle. We as humans, whether we want to or not, we are directly linked to it. We're a piece of that chain. It's like a bicycle chain, if you've ever ridden one. We are part of that cycle, and by tracking those rates, even in a small neighborhood, because we're all downhill from someone, no matter what watershed you're in. Is that type of modeling being done? If it hasn't been done, or is that something within the consideration? I remember, I think a lady had asked you before, well, how can you simplify it? What could be a simple answer? I love simple answers, and the simplest thing is the simplest type of bioswale, and that's a rain garden. By letting the average individual understand that, yes, I am a part of the water cycle, and I can make a difference by building this little small watershed facility. And then using that data to see how it not only affects my groundwater, but lakes, rivers, because they're all linked. Everything's part of that chain. If we're looking at gaining and losing, it's the same it falls within an open loop system. We're not really in a closed loop system. So I'm asking, are we beginning to consider that? I know it appears to be small scale, but sometimes small things are good things, and it's a baby step. And baby steps are awesome.
Yes, I totally agree with you. I think I mean, there has been modeling that has been done looking at groundwater pumping and effects on stream flow. And there has been some work that has been done looking at, you know, adding water back in, infiltration. I haven't done that, but there has been some looking at infiltration and how that could affect streams. We haven't done any of that at this scale. I mean, this is a statewide model, so we're pretty coarse as to what data inputs that we can include. But I think if you were interested in looking at what actions could be taken for a specific watershed, then that would be a good scale to kind of look at that. You know, where could you do different infiltration projects? Where could you make changes with groundwater pumping or diversions, or, you know, that sort. I think those sorts of models are developed, but
not necessarily even. I'm trying to get people to, in a sense, passively. When you begin to harvest your own water, you get very water conscious. If you only have I have a 130-gallon rain barrel. It's amazing how fast it fills, and it's amazing how fast it goes. But when you begin to harvest your own water and use your own water, not only are you slowing everything down, but now you're allowing time to how can you say, not use so much of the municipality's water, but you're using your own supply for your garden or whatever. You could take it further, but I really want to keep this as simple as possible and to say there are simple things we can do. There also are things you can look at as far as pumping and ejection or flood mar, but I want to, and my hopes is to keep it very simple so that the average everyday individual will feel like they are participating in their stewardship of water. And I guess that's the goal here, that where you guys are reaching towards. And there's been, from what I can see, a lot of good information, but not a lot of good how different watersheds, let's say up towards Napa, since you guys brought that up. If a certain neighborhood was pretty well established in harvesting water, how is that affecting that watershed? Is it rehydrating? Is it how much water is going back into the watershed? I think it'd be, maybe because I'm goofy this way, but I think it'd be fun just to get the data. But also, I'd like to see what happens with the rivers. Or do we start seeing it rise, or do we begin to see it even get stable? I think the biggest question I get is like, well, Dennis, it doesn't rain. Well, you're quite wrong. It rains a lot. It's just that we don't use a lot of rain. We just let it all flush down to the ocean. And by getting small neighborhoods to act with the communal effort, you can begin to see your watersheds not necessarily increase, but at least stabilize through the summer.
yeah, I think, you know, depending on the size of the watershed, smaller watersheds, for sure, that could have a difference. And it you know, there's I think there's some things that are just best practices, you know, reducing your irrigation at your home and doing some, like what you're talking about, those actions are best practices for people living in a watershed where we have drought. And I totally agree with that. I think it's different to say, you know, it's harder to model the effect. If you know, you could do some models to say, like, how many people would it take doing these practices to make a measurable difference in stream? I haven't done that, but that's something that could be done. It would have to be done, I think, at the local, you know, like a watershed scale rather than statewide to make it useful. But that could be done as well, just to know like how much you would have to scale that to make a difference in what you actually saw in the river.
Yeah. If nothing else, it'd be a good fun. It's always good to just get everyone to really get that feel of like I'm playing a part of it. Yeah.
Right. I agree. I mean, I think that the more people that feel invested in their watershed and what they do on their property, the better.
Yeah. All right. I don't want to take you too far down the rabbit hole. I'll let you guys continue. But thank you for answering.
Yeah, thank you.
All right. Any other questions for Julie? All right. Thank you, Julie.
Yeah, thanks so much.
Let's see. I have 11:25. I think we only have one major agenda item left, which is our drought update. So I think we can go ahead and push through these. I can go ahead and start these off. So I don't know if we have all staff for all of our regulations that we have in effect right now. But we can start with the Russian River. And since Sam is on this meeting, I will let him give an update on the status of the curtailments in the Russian River watershed.
Yeah, hello folks, this is Sam Cole, State Water Board. Yeah, so we just actually recently pushed a new update for the Russian River curtailment. We have basically check the curtailment status list on our website, on our drought page. It has the updated list of the curtailed water rights in the watershed. So when we did the August 1st update for things are actually looking pretty good for August. But that included augmentation by through the Potter Valley project, releases from the Eel River into the Potter Valley and flowing through the main stem, which provided access to a lot of the appropriative water rights throughout the main stem of the upper Russian River. In fact, there was enough that it was a surplus to meet those demands and was feeding down into the lower and assisting with the lower as well. But unfortunately, there was a PG&E variance, FERC variance that was basically went into place at the very end of July. And so now, unfortunately, the flows have been significantly reduced. They were roughly like 80 CFS of additional flows coming through, and now they're supposed to be as low as 5 CFS, but with we're running it. We basically use the average flow with the Capella gauge, and it was around, I believe it was around 17 CFS, so significantly lower. And unfortunately, there are a number of curtailments to the watershed. Also, with the evaporative losses along the system, there's pretty much none of the natural flow is making it to the main stem, so significant shortages for a lot of riparian right holders. And then with the voluntary sharing agreement, which was in place for July, it was working pretty well, but unfortunately this is a pretty big hit, and it reduces the flows that are available to be shared. So we're still kind of monitoring that. But yeah, I encourage folks to go visit our drought website and click on the regional. There's the regional links. You can click on the Russian River watershed and check out the latest information there. You can also sign up for the LIRIS distribution to receive updates. We're constantly monitoring forecasted, precipitation and climate conditions and updating models as needed, and also monitoring the augmented flows, additional flows that come in from the Eel River through the Potter Valley project, and trying to keep as up to date and keep as much notice for folks as possible. I know that's really critical to be able to, it's difficult to operate and you don't know how much water you're going to have. So we're trying to provide as much advanced notice as we can for folks, but just know that it's kind of tricky with both with the natural flows, with these odd kind of storm events that we've continued to have even into summer, as Julie kind of mentioned. It's kind of an odd thing, but also combined with the Potter Valley significant decreases in the Eel River flows, it makes for a tricky management scenario. So anyways, yep, that's kind of the update. If there's any questions, thanks.
Any questions on the Russian? Chris.
Yes, thank you. Could you repeat what you said about the voluntary participation of the diverters to try to keep more water in the stream? How much participation did you get, and how effective was it? You slightly mentioned it, but I think I missed it.
So
Yeah,
I can go ahead.
I don't. Yeah. Thanks, Dan.
Yeah, so that voluntary agreement is a water sharing agreement. It's not necessarily an agreement to leave more water in the stream from the diverters. The Russian River emergency regulation looks at, it's more of a water allocation regulation and curtailment order regulation than it is in-stream flow requirement regulation. It's designed to support the main stem and stream flows coming from the reservoirs and ensure that there's enough water to support those, plus minimum human health and safety needs.
Okay, so that was curtailments on the Russian, and you said it didn't go very well?
No, it did go very
said
well
it, yeah.
up to the point that now that flows have dropped from the Eel River. So for those not familiar with the Russian River, the flows that actually come into the Russian River from the Eel River are significant to the water availability in the Russian itself. So when the flows dropped from, I don't know the exact number, but down to 5 CFS, what that meant was that there was no longer enough water under the voluntary sharing agreement to allocate to junior users. So it is no longer in effect at this point because the flows just dropped down below the threshold of sharing.
Ah, okay.
Yeah, and to
And I
elaborate a
know,
little bit further on that, the specific reason why the program was suspended was because one of the major components that needed to be in place for that to work was the ability to ensure that there was no adverse impacts to non-participants. And so it becomes increasingly difficult to be able to prove to the analysis that there's no impact to non-participants once the flows decrease to such a minuscule level. So as of August 5th, the program is temporarily suspended.
I know Jessica is on the call, and I was wondering if she could comment on the Napa voluntary program with the farmers here to get them to cut back on their water use. That's I know it's off your agenda, but it's in the same vein that we're currently speaking. I'm very curious about that.
Yeah, so Chris, that would fall under the additional updates. So why don't we go ahead and we'll run through the regulations component of the drought updates, and then let's flag that to make sure that we cover that in the second half of this agenda item. Does that sound good?
Sounds good.
All right. Any other questions on the Russian before we move on? All right, I know I have Dan Worth on the line. Can you give an update on the Scott Shasta regulations? Or I had Dan Worth on the line. I don't know if he is still on there. Well, we lost Dan Worth. Do I have anybody from Bay Delta that can give an update on Bay Delta related regulations? All right. So let's move over to Chris's recommendation. I don't know if the person that she was flagging is on the line for the Napa.
Chris, I don't know if you're talking about me, Jesse Maxfield with CDFW Region 3.
Yes, thank you.
I am on the line. To my knowledge, we haven't had anybody sign up for the Voluntary Drought Initiative program in the Napa River watershed, but I think, is Shay on here? Oh, okay. It looks like I just got a message from her. She's not on. She's jumping on now, she said, but we can put her on the spot and see. But I do have, we have a field tour tomorrow, not related to the Voluntary Drought Initiative, but I'll be out there with some of the folks from the Napa RCD, and I'll definitely check in with them to see, because they were kind of helping with some of the, outreach associated with that in the Napa River watershed. But to my knowledge, we don't have any projects in the Napa River watershed, unfortunately.
Yeah,
But
because we got dry riverbed, and the Napa River flows are terrible, and dry riverbed. So a repeat from last year. So I was curious to see if, all these farmers and all this groundwater pumping and diversion, if anybody stepped up to try to make the situation better, but it doesn't sound like they did.
Yeah, we did some outreach there, and to my knowledge, we did not get any takers. Shay, are you on the line? I don't think she's there yet. But anyways, I'll have her follow up with, this is Chris, right? Chris Malin?
Yeah, thank you.
Yeah.
Yeah.
I'll have Shay, I'll ping her to follow up with you and let you know if there's anything that I'm not aware of. But I'll also check in with some of the folks that we're going to be out there with tomorrow, because there may be some something going on that I don't know about.
Sounds good. Thank you.
Sure.
Okay, so any other drought-related updates? Do we have any grant funding updates or anything else anybody would like to share? Okay, hearing none. So let's see, that brings us to wrap up action items and potential agenda topics. So thank you everybody for attending today. I don't know if we caught any action items. It sounds like there'll be follow-up from CDFW with Chris on the Napa River. I didn't catch any others. Did I miss any that people had? All right. Does anybody have any potential agenda topics they would like to work on adding or present on for the November 8th meeting? All right. If in the meantime you have any that come up, please feel free to email me any agenda topics that you would like to hear more about or present on. As always with agenda topics, it's always helpful for us to have kind of participation to help flesh out those agenda topics if you come up with some. So feel free to email me if is there anything else? Looks like somebody does have a hand up, but I don't know who.
Hi, Daniel. Hey, it's Kimberly.
Hi, Kimberly.
This may be another one of these layperson questions, but is there some way we can get a little presentation on how to get a stream? No, I don't know what you want to call it. The environmental flows established for a stream. Just kind of a walkthrough on that. Just maybe Julie or somebody like you could do that so that the public has an idea of what is involved, and maybe how you guys can assist. Does that seem appropriate?
Yeah, sort of a presentation on kind of the, if you will, kind of the framework of flow criteria development to flow objective development through the different agencies' processes, or where that would go off to a local implementation as well.
It was my understanding, maybe I got this totally wrong, but my understanding was that in order to actually have your stream figure, just the natural flows, environmental flows for your stream or to be established, you had to do a certain amount of more data gathering in that particular area to come up with a number for the certain times of the year, and maybe that was a total misunderstanding on my part.
Yeah, so the general process is that, which is kind of what the environmental flows framework lays out, is the first step is kind of analysis of the issues in your watershed or area of interest, and then developing information to support what the ecological needs are in that location of interest. That's kind of where if you will, where you kind of hit either the local implementation plan to develop an environmental flow recommendation, or it would come over to the state water board to develop flow objectives. And that information, then when you move into the next stage, there's additional information you need to try to balance and evaluate how best to try to meet the ecological flow and other beneficial uses of water. And that's either through the state water board process or through a local cooperative solution. But there is if it moves through the state water board process, typically there is the CEQA involved, which does evaluate looking at a variety of different impacts and so on and so forth. And so that's kind of where the robustness of information increases. If it moves through more of a local cooperative solution, then that would be more of that step wouldn't necessarily need to be developed if agreements could be reached at a local level.
Daniel,
does
it's
that kind of help big picture?
Thank you, Daniel. Yeah, I'm a little still confused, but I can take this offline. Go ahead.
Daniel, do you mind if I respond to what Kimberly just brought up? It's Conrad.
Yes, please do.
Kimberly, this is to me and others the key question. How do we convert in-stream flow recommendations or criteria into actual in-stream flows? And I brought this up at previous meetings and was asked to turn it into kind of a side conversation. So to that end, I've put my contact info if you or others want to join, transitioning from in-stream flow recommendations into in-stream flow requirements. And I think there's a long history of answers as to why past recommendations have not become actual water for fish. There's also misunderstandings about what the law says. Like technically the law you do not need to compromise scientific-based recommendations for economic impacts if it's based on Endangered Species Act. There's also disagreement about whether you need CEQA for each and every in-stream flow requirement. So as long as it's going to remain a side conversation, that's what I'm proposing. I mean, I think it's fundamental, but my info's there if anybody wants to join that. Thank you.
Yeah, and that's where I would just build up, what Conrad mentioned from our prior discussions on this, is that the purpose of the Water Quality Monitoring Council is really more of the collaborative, not regulatory side of things. And so when it moves into the regulatory side of things, that would be outside of the scope of this meeting group. As far as providing information on what those different processes look like and so on and so forth, I think that's within this group, so that everybody has a clear understanding of how SEF and development of ecological flow recommendations and criteria, as mentioned, kind of fit into a regulatory framework, or what the paths forward are with that information to actually implement it and see a meaningful change on the ground. This is something that we're currently working on, actually, to try to put together some information that helps better inform how SEF fits into different regulatory agency proceedings. And hopefully by the next meeting, that would be something we'd be ready to share, kind of that flow chart and kind of how it all fits in. There's outside legal debates, which would not be appropriate for this meeting scope, but would be happy to bring, to have a side meeting on that if folks want to have that.
I just simply wanted to know, what the environmental flows are for my creek. That's all I really wanted to know. Of course, there's lots more, but and I thought we were getting close to being able to figure that out. So, and I thought maybe, I don't know if it's something that Julie could kind of help with it. Maybe we need like a little local stakeholders group to figure that out. And then it's just a number or some numbers, but it's not regulatory or anything. If they're just some numbers that we need, if that's possible through stuff, that would be awesome.
Yeah, and I think I would broadly look at section A and B of SEF. You know, part of the intention of SEF was to help develop that information at whatever scale of interest parties have. And so if that's something of interest, then moving through those steps, acquiring funding if needed to help support that effort, so on and so forth, would be the appropriate path forward from my perspective.
Yeah.
I don't know if any of the other tech team want to weigh in.
That was my understanding, Daniel, and that's kind of where I wanted to take those steps. But I think of just fumbling and haven't made very much progress, but I'll reread that and see where we can take this. Thank you very much.
Mm-hmm. Chris, did you have a question or comment?
Yeah, I have a suggested topic or speaker possibly from Department of Water Resources, and we've visited this topic before and we've slightly touched on it, but it's pretty significant, these groundwater sustainability plans being approved by DWR. And in our local counties, we bring up SEF as a way for the counties to weigh in on their groundwater sustainability plan and meeting one of the criteria of not having an undesirable result from groundwater pumping that hence then dewaters a stream. And so it is a criteria that DWR looks at, and it has been mentioned SEF could be one of these modeling tools that the groundwater sustainable agencies could rely on to help them develop their plans and meet sustainability for groundwater by, you know, the deadline of another 20 years from now. So I'm wondering if DWR is looking at SEF and how they're looking at it and how they might use it or in their assessment or recommendations to the local GSAs about meeting the groundwater sustainability plan goals and objective of getting sustainable groundwater in our state. Is SEF having discussions with DWR, and if they are, what do those discussions look like, and how is DWR leveraging SEF for GSPs?
Okay, I think that's a good topic. Do I have anybody from Water Resources that is on that I can coordinate with between now and the next meeting on that topic?
Dan, this is Eric. I put a comment in the chat about a case in Southern California where this is being done that I don't know if it'd be ready by the next meeting, but maybe at a future meeting could serve as an example where SEF is being used in the development of a GSP.
Okay, thank you, Eric. So yeah, we'll work to flesh that out, Chris. I'll try to reach out to some DWR staff and see if we can coordinate on a presentation. And then also, as Eric mentioned, if that additional presentation is ready, we can go into that next meeting.
That sounds really good. Thank you.
Okay. And I was just getting caught up on the chat. I didn't have it open, so I see that there's some notes there that we can work through as well. Anything else that anybody would like to share today? All right, I think that brings us to the end of the meeting then. Thank you all for attending and look forward to the next meeting. If in the meantime you have any questions, comments, or agenda items, please feel free to reach out. Thank you, everybody.
Stan.
Thank you.
Thank you.